Alrighty.
And multiply by.
What would it look like in figure 4? What would it look like in figure 10? And what is the pattern? So I guess we're just supposed, I don't know where we write that.
IDK.
Hi, folks. That was an excellent question. That's the question that's going to guide your entire process on your first slide, the 5 representations of a function. So you'll complete that slide, you'll insert a graph, you'll complete the table, you'll write a real-world story problem and an equation. And all of that's going to help you to think about the 4th and 10th figure.
All right, math brains, where we at?
I'm trying.
Right, a real world story problem. So what are you doing with just adding 4 every time? Should do something around that.
You don't know what I'm talking about?
Yeah, I'm just trying to figure out how to word that. Like, as a real world problem. Like each year you add 4, maybe you could say, you have 4 children and each year they give you a new brick. Or you're
really getting detailed with it then.
halfway. Well, I mean, it's supposed to be real world.
Yeah.
Yeah. I'm working on the figure 4 and figure 10 because she wants a representation. So I'm trying to get those drawn right now.
All right, so where are you doing this, Tina?
On a piece of paper, and I'm going to take a picture of it.
Okay.
All right, I'm going to do the graph, but I just need to get the right one, sorry.
So right now, Austin, you're using a Desmos calculator, and you're going to be able to copy it and put it there?
Yep.
In that block? The technology is what's got me.
Are you on your laptop, Jim?
Yeah.
You can find a snipping, it's called snipping tool, I think. And anything you have, it just cuts and pastes what you have on your screen, takes a picture of it.
So we're supposed to be looking at what figure 4 and figure 10. Okay, so
I'm drawing those right now.
Okay, so based on the image above.
So figure 4 is going to be 4 and 20.
Area B.
Like
Laura,
Yeah,
can you?
I can.
I can't figure out where you guys are.
Okay, we are on slide 20. Go down to
I'm
slide
looking
20.
at that. Okay.
Okay, so this,
What?
where it says figure 2, right here.
Yeah.
I mean, you can't say, okay. So what we did was we counted the number of blocks in a side. What changed from that figure to figure number 3? We have to be able to write a formula down here. Okay, so then one of the questions back in like slide 6 was what would figure 4 look like? And so we said 4 would have 6 blocks to a side.
Hi there, group. You mentioned just a second ago that you saw how much more figure 3 had than figure 2. Since we've got these little colored blue blocks, can you show us, like with a different color, what are the new ones and how did you figure out that 4?
Ooh, it's red.
Yeah, so that one would be a new one. And let's make that one a new one. So if we took all the corners away, then we're back. No. Does that do it? Yeah. Take all the corners.
I see it. So you kind of like see that all 4 sides being like pushed out and then getting 4 new posts.
Yes.
Neat.
Mm-hmm. So then 3.
Okay, so anyway, how can we visualize figure 3 in a graph? Oh, so somebody put table? Who put table?
That might not have been us. Because anybody can write on that slide.
Oh.
Yeah, that was the anonymous armadillo did that. Whoever he is.
Hey folks, I was trying to have students make the relationship of like, where do you see figure 3 on the graph and where do you see it on the table? Because how many of you have students who like think that tables are for one chapter of the book and graphs are for the other and they don't like recognize that they're the same thing?
A lot.
Yes.
Right? So in this case, like where do you see figure 3 in each of those? Like can you pinpoint the spot where you see it? And hopefully get students to see that they're just different representations of the exact same thing.
Can we put them on slide 5? Let me paste it on slide 5. So if I put them here on the side,
How about on slide?
I put them on slide 8.
Okay.
Can we see them on slide 8? Does that work?
Yeah, we're on the slide.
So how can we visualize figure 3 in a graph?
Figure
So figure 3 is where. I would graph it as 316. So that's going to be an increase, but it's
the whole group discussion and be prepared to share. So I'm assuming at the end when we all go back to the main room, we're going to be sharing our slides. So we need to decide who's going to do the talking for our group.
Well, does everybody have the same problem?
Hi, folks. We're
Hi.
gonna, Tina, you're exactly right. That's usually what we would do here. Today, everyone has the exact same problem. So we'll just be talking about the discussion questions kind of as a whole group. But before you head to those, if you all want to take a peek at your purple slide and see if you can match up those terms with those graphs.
Okay.
So what is the next slide we're going to?
15.
15.
Okay, so we need terms. Oh, right. What?
Hey there, group 4. And then just being the 2 of you, huh?
Yeah, and she doesn't teach this kind of stuff, so we're trying.
So what do you all teach then?
Well, I kind of,
Math 6.
she does just math 6, I do math 6 and some of math 7,
Mm-hmm.
so I touch on slope.
So Math 6 definitely has that algebra strand where they're looking for those growing patterns. And so the table and the story problem and the figures should be at least somewhat relatable in Math 6 there. But I see you guys have those ones already done.
Yeah.
Oh, so working on the story problem. So like, why might this growing pattern be happening? What in the real world kind of grows that way?
Like, I'm trying to think of things that our kids would understand and how they would relate to it. I mean, like if they did like if they had a collection of books or toys or something.
Awesome. So if they had this collection, how many things did they start off with?
Well, they started off with one. Well, you had them start off with one. You know, my brain just like left me on that one.
That's all right. So in this problem here, you all didn't actually start at like day 1 or collection point 1. The whole thing started at like day 2 of collecting things. And that's what makes this a little tricky is it doesn't show us the first one and it doesn't show us like how many you started with before the first day. So thinking about this on day 2, how many like squares did there end up being?
On day 2, there was 12.
Cool. And then day 3, there were 16 according to your table. And so that's kind of what your story problem can be written as. You know, day 2, there's this, day 3, there's this. Each day we keep getting some amount more. How many might we have? And then you can keep going with that.
Okay. Okay.
Cool. Keep thinking about it.
Who's typing on 25 right now? Is that one of us?
Matt. He's the neon cat.
Okay.
Neon cat.
I'm not neon cat. How am I neon cat? I don't even know what that means.
Well, you said that the y-intercept meant that if you had an enclosed space, no enclosed space, right? If you had no enclosed space, you would need
Yeah.
4 blocks.
You need 4 blocks. Yeah, that's what he said.
And then the x-intercept was if you had x-intercept would be
X-intercept is just out of the
0
zone.
blocks.
I mean, the X-intercept
is not
if you-
possible.
if we're just talking about those pictures. There's not a picture that we could draw to represent the X-intercept. We've evaporated into some sort of alternative dimension or something.
So when I hear students say that, I know where they are in their mathematical progression. Why is it so hard to draw a picture of x-intercept? What's happening there?
Our x-intercept's a negative number, which doesn't make sense when you're representing it with the figures.
It's like negative
We're out of the domain.
So what real world example could those figures be where all of a sudden you could have some kind of negative?
Like, are you asking where we could have negative, like, example, you're talking about, like, money? Like, being in the hole?
Cool. Okay, yeah, so let's go with money. What would that look like then? An x-intercept.
Like, how much money you have in your wallet?
That'd be like a X was 0. Y was 0. Well, if you think about it, money, you can think of
the stats. And it's kind of cute. I've got one girl who doesn't speak any English, and
All right, we gotta go.
Hey, folks. So what grouping do we have here? Is this the group of folks who weren't in the original list?
Yes, it is because we have, these are my 2 4th grade teachers that are watching today to learn how this works and if it might work in a 4th grade setting.
Oh, really cool. Hi, 4th grade teachers.
And they figure out how to get out of the main room.
So the interesting thing about this problem is it actually originates as a 4th grade problem in just a growing pattern, although usually we would see figure 1, figure 2, figure 3. And they would relate it to a story problem. And instead of writing the symbolic representation as an equation, the students would say, like, we start with blank and we add blank each time. But some of our folks in secondary don't necessarily see that connection to 4th grade. So when it comes out, I'd love for you all to be able to make connections to this so that they can see the connection that they have to 4th grade.
Okay. Well, good. That's going to have to be you, Shelby. Because Pam can't figure out how to get her mic on.
All right, I'm going to pull everyone back in the main room now.
I don't know what to say about that.
Hello, everyone, and welcome back. Hello, hello. Welcome back to the main room. Hi there, everyone.
Hi.
Hi, welcome back. All right, I'm going to go ahead and mute everyone's microphone. And if you're going to talk, just make sure you turn it back on. So in this example, I was trying to model what it's like when we give all students the same problem, the same work time, and then the same discussion questions afterwards. This will be a little bit different tomorrow, but I'll model lots of different things so you can get some great ideas for your class. So in this case, you all were given a problem that is technically written for a 4th grade class that's been beefed up a little bit. In 4th grade, they learned this idea of a growing pattern. They also learn how to draw pictures based off of a real world story problem where something is growing. And they might not have y equals 4x plus 4 yet, but they do start to write in words what they're starting with and what they're adding each time. So those of you who teach anywheres in that 4th grade through 6th grade, I'll have you start off first. If you don't mind turning on your microphones and letting us know, like, what about this lesson might you be able to use in the 4th through 6th grade class?
When I look at slide 20 and I see the Desmos online manipulatives, I look at that and I think that's definitely something that in 4th grade we have them create patterns. They could create patterns using those online manipulatives.
Excellent. And on slide 20, they did a nice thing with the color there, so you could really see like what's changing, what's new each time. One thing that's typically tough for students in this early algebra reasoning, and quite frankly, as someone mentioned, even in the AP courses, is seeing the connection between the table and the graph. If someone will go ahead and turn on their microphone, tell us what slide you're on and how you can visualize figure 3 in the table and the graph. And I'll call on someone. How about in group 3, since you already have an arrow there at the table? Come on down to slide 14, everyone, because they already have an arrow. And would you all make a copy of that arrow? Show us where that is on the graph. On slide 14, where is that figure 3 on our graph? All right, so let's get someone from our group 3. Turn on your microphone and tell us, where do you see it here, and how are these two things the same?
Those are the ordered pairs that make up the line.
Awesome. So we're mentioning more about this idea of ordered pairs. How many of you all have students in your class who thinks that tables are for chapter 4, graphs are for chapter 5, and they don't see the connection? If that's happened to you, turn on your microphone. How might an activity like this support them in seeing that those two things are the same thing?
So I teach 7th grade, where this is right what we're talking about, and we do activities like this. This is actually when all of this hit, I used an activity from Desmos to teach slope, and it was almost very, very similar to this.
Yeah, and the other thing that's kind of unique about this is that idea of writing the story problem. I don't know how many of you all thought that the story problem was either really easy or really rigorous. If you'd share with us what makes writing the story problem either really easy for you or really rigorous.
It's easier for me to start with the story and then make the equation fit the story versus looking at the equation and then trying to write a story for it, I think. Because I guess I'm starting from the ground up and putting the numbers in myself versus trying to figure out the numbers and then writing the story.
Right. And who feels either the same or different?
I'm not sure I feel the same or different, but I think it's a conceptual thing. I mean, it's a totally different conceptual way of looking at the problem. A lot of people can do the math, but can't see what doing that math actually did to something in real life.
Right. And then when we don't have that connection to real life, that's when we get all those misleading graphs that we talked about earlier on.
I think the story problem also helps to answer or can help to answer the questions that a lot of eighth graders have, which is, when am I ever going to use this? Why will this matter in real life? If you can't take those numbers and connect them back to a real life situation, it's hard to get the kids to buy in and to think that this matters for anything other than an SOL test or a unit test or whatever.
Yeah, and, I think the big thing is to show the slope is just can relate all kinds of things. Like I think me in particular, I have kind of a physics background, and I always want to do like some sort of physics example, and I have to really force myself to say, oh, let's turn this into something about how long medicine stays in the bloodstream or something. I think it's good if you can show that there's a variety. There's like a wide variety where this is used. It's not just one type of situation. Like on that one, I got thinking geometrically as soon as I saw the geometric example, and I really was having a hard time getting out of that. And,
Yeah. And I heard a lot of groups thinking very flexibly, trying something out, challenging one another. You all worked really well like that. So yeah, let's ask. There's one more question that's I'm kind of thinking about here. You all have these lovely graphs going on. Some graphs dip into the negatives. And that brings us to the last three discussion questions. What's the difference between that real world problem and the math representation in terms of things like x-intercept, y-intercept, domain, and range? How's your graph different than the story problem in terms of those?
In group one, our word problem was saving, starting with $4 and saving 4 per week. And then that would not work in the negatives backwards in time.
Awesome. Right. So your graph is a beautiful model, but technically in your story problem, it would only be the positive side of the graph that we'd look at.
right.
Does anyone else have a similar story problem or similar situation with your graph?
That was the same with group 3. It could kind of only be positive.
Okay, so you're adding a new brick to your garden path. Again, we're not going to have negative bricks. That doesn't really make a lot of sense. All right, and then you all saw with the purple slide, one of the things I was trying to model here is how you can do a simple matching activity. We have the images and they're just matching these terms. But those of you who are here, you've got this math background. What was challenging about the matching activity? Did anyone want to change any of the terms? I usually get at least one group who wants to change one of them.
Well, the decreasing rate ended up in D kind of by default because all the other ones said whether it's increasing or decreasing, and then also at a constant rate or an increasing or decreasing rate. So that one, the fact that it didn't say decreasing at a decreasing rate might have been made that one kind of have to go in there last and process an elimination, which decreasing one doesn't have one yet.
Right, and so I'm on slide 24. Sometimes what I'll have my students do, if they get really into this, is they change the color of the box too. They say, you know what, we don't like this one, we're going to change the wording on it. And I'll sometimes even just put one without words on it and ask them to fill it in to give them a little bit more rigor with that. So it's not just like your regular matching activity. You can make it a little more challenging for them. All right, folks, our final thing for today is on slide 26, 27, or 28. They're identical, so pick a text box there and tell us something you know about that graph. What is something you know about that graph? Once you have something written there, go ahead and either type in the chat box or turn on your microphone. How might you use this style of exit ticket in your class? How might you use this style of exit ticket in your class?
So Matt was already mentioning about statistics and representations of data. So I know especially early on in the curriculum, we talk a lot about how what are good things to do in representing data and what are things you should avoid doing. And so it could, see putting up a bad graph and be like, what are things that are wrong with this? Or, a pie chart that adds up to more than 100% or, whatever it might be. Just to get them talking about here's what I see that's wrong with it. Here's what I see. There might be many things.
Tim, what you're mentioning right there with many things is a great application. There's lots of text boxes. It's relatively anonymous unless you're watching them, type in there. And there's places for many answers. As soon as all the boxes are filled, I'll make another slide. We can have infinite number of answers here. Jay, tell us about how you're thinking for vocabulary review.
Just in 6th and 7th grade math, checking their understanding of all the vocabulary when we're talking about linear equations or functions and the different parts that go along with that. I could see using this to kind of see which words they know, which words they don't know, or which ones they're confused with.
Absolutely. All right, folks, so today we kind of took a look at a routine called Which One Doesn't Belong? And then you went into breakout rooms for the entire math work time where you all had the same problem to do, focusing on conceptual understanding, and then you had a matching activity. We came back together, had a whole group discussion, and ended with an exit ticket. I'm going to ask you all to think about these different activities, how you would implement them into your classroom. And when we come back tomorrow, we're going to be doing things a little differently, but it will still relate to mathematics. And it will still be a problem that you can take pieces of it and use it in 6th grade math all the way through high school mathematics. So again, we'll have a large range of topics and ways you can tweak it. So I will move to the Q&A section. If you have everything you need from this, feel free to log off. If you have questions, I'll stay tuned for the next 5 minutes or so and answer them. Again, all the templates are available on slide 29, and I will upload this template today so that if it's something you want to use in your class immediately, you'll have it available. Happy online learning, everyone, and see you tomorrow. And what questions do we have for the virtual parking lot? You're welcome, Tina.
I guess my question might be for Pat as well as for you, Teresa.
the fact that you're using this is Blackboard, correct?
Yes.
To do this?
Mm-hmm.
Okay, so